Hey everyone, a huge welcome to all of Mr. Cheese students and followers. He reached out and asked us to do a special explainer on a genetics question that can be a little tricky. So that's what we're gonna do. Let's crack this code. You know that feeling, right? You look at one of these pedigree charts and it's just this web of squares and circles and you're not sure where to even begin. Well, you're definitely not alone. But don't you worry, by the end of this, you're gonna read these things like a total pro. So, Mr. Chi pointed us specifically to question 2.4 from your Life Sciences Paper 2. And our mission today is super clear. We're going to walk through every single part of it to make sure you can grab every last mark. You ready? Let's dive in. Okay, so before we even try to answer the questions, we have to understand the rules of the game, right? Let's take a quick moment to decode the blueprint of this whole problem. The first thing to lock in is that we're dealing with an X-linked recessive allele. Let's break that down. X-linked just means the gene we're talking about lives on the X chromosome. And recessive? Think of it like a shy gene. It only shows its trait if a stronger dominant gene isn't there to overshadow it. And we're calling this recessive allele XA. Now, for the chart itself, this is basically a visual language. And it's super simple. Squares are for males, circles are for females. If a shape is filled in or shaded, that person has the syndrome. If it's unshaded, they don't. That's pretty much it. These simple rules can tell a whole family story. All right, basics are down. We're ready for the main event. We're going to go through this question step by step, taking it down piece by piece. This is how you score points methodically. First up, 2.4.1 Part A, give the phenotype of Liz. Now remember, phenotype is just the fancy scientific word for the physical trait you can actually see. So what do we observe when we look at Liz on our chart? And there it is. We see a circle, which means she's a female. And that circle is shaded, which means she has the syndrome. So she is a female with X-linked Alport syndrome. Boom, easy marks. Don't overthink it. The chart gives you the answer. Okay, next up, genotype. This time, we're not looking at the outside trait. We're looking at the genetic code on the inside. So what is Nate's specific combination of alleles? Well, Nate is an unshaded square. Square means he's a male, so he has an X and a Y chromosome. Unshaded means he's unaffected, and because this is an X-linked trait, his one and only X chromosome must be carrying that dominant, healthy allele, so his genotype is XAY. Another 2 marks in the bag. This next one is a pure observation question. It's asking us to scan the entire family tree and just count. How many unshaded squares, males without the syndrome, can you spot? The answer is 3. Let's find them together. We've got Nate up in the first generation. Then, if we look down at the next generation, Brenda and Abe have 2 sons. Both of them are unshaded squares. So that's 1, 2, 3 in total, an easy point just for careful counting. Okay, now the questions start getting a little bit spicier. We need to figure out Brenda's genotype. We can see she's unaffected, right? She's an unshaded circle. So we know she has at least one dominant XA allele. But what about her other X chromosome? Is it another dominant XA, making her homozygous? Or is it the recessive XA, making her heterozygous? The answer is heterozygous. She's what we call an unaffected carrier. But here's the thing, just knowing that isn't enough. The real question is, how do we know? And the proof, like it always is in these charts, is found in her children. Which leads us right into the final and most important part of this whole question. Okay, welcome to the high flyer section. This is what separates a good answer from a perfect full mark answer. If you really want to guarantee you get all the points for these tricky explanation questions, you have to start thinking like an examiner. This is it, the 2-mark explanation. Why must Brenda be heterozygous? The key here isn't just about what you know in your head, it's about what you can prove using solid evidence straight from that pedigree chart. So here's the foolproof 2-step logic to secure both of those marks. First, look at their daughter, Liz. She's affected, which means her genotype must be XAXA. Now for step 2, we trace those alleles. Where did they come from? A daughter gets one X chromosome from each parent. She got one XA from her dad, Abe, who's affected. So where did that other XA have to come from? It could only have come from her mother, Brenda. And that's your concrete proof. And this is exactly what the examiners are looking for. They'll give you 1 mark for using the daughter's genotype, XAXA, as evidence. You could even mention her unaffected sons. But the key is making the connection. Brenda herself is unaffected, but since she passed on that recessive XA allele to her daughter, she must be a carrier. Her genotype has to be XX. So the most important takeaway for any pedigree problem is this: the children are the clues. Their phenotypes, their genotypes, they reveal the genetic secrets of their parents. Always, always link your explanation back to the offspring. And just like that, question 2.4 is completely cracked. Fantastic work! See, that's how you take what looks like a confusing question and turn it into guaranteed marks. And to keep this awesome momentum going, you know exactly what to do. To keep leveling up your science game, you have got to be following Mr. Chi on Instagram, TikTok, Facebook, and YouTube. He's always dropping amazing content. And hey, if this breakdown helped you, pay it forward. Like it and share it with a classmate who's also trying to crack the genetics code. It helps everybody out. Thanks for tuning in to this special explainer. Make sure you drop a comment on Mr. Chi's page and let him know which question you want us to tackle next. Until then, keep up the great work and happy studying.